Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are doing fine and staying safe. Previously, in this chapter, we actually started from theorems of Boolean algebra. Then we studied combinational circuits like full adder and half adder circuits. And then we studied sequential circuits like SR flip flops and JK flip flops. Today would be the last of this last lecture of this chapter, which would be about Karnaugh maps. And let me tell you that Karnaugh map is actually a way of simplifying a Boolean expression. Karnaugh map actually lets you find the sum of products, which creates a min term. A sum of product is actually an expression where products are added. For example, you're having A dot B dot C plus A inverse dot B dot C, so that would be sum of two products of a Boolean expression. So sum of product is where the product of a Boolean expression are summed together, added together. K-map actually helps us find the simplified expression, the simplified way of expressing the Boolean expression. Consider this simple truth table of XOR gate from your textbook. If I would want to make the K-map, I'm only going to focus on the columns where I have ones. In the second row, I can see A inverse dot B is giving us a 1. In the third row, it's A, B inverse, and in the last row, fourth one, it's A and B. Remember the rule that you learned in the O levels? If there is 0, it's A inverse. If there is 1, it's simply A. Now, if I have to plot that on a K-map is going to be a table like this. The number of variable raised to the power of 2 is the total boxes that we would like in our K-map. Currently, it has 2 variables, so 2 raised to power 2 is 4. So in my K-map, in the table, I'm going to have 4 boxes. In those 4 boxes, I'm going to actually place ones wherever 1 is. The first one is actually A inverse and B. Remember, when you are plotting the variables on the K-map, the rule is to plot one variable on the x-axis and the other is on the y-axis. If we have 2 variables, we are going to have one of them on the y-axis from top to bottom and 2 of them would go on the x-axis. I'm going to show that you in just a minute. So starting from inverse, first one is A inverse and second one is B inverse. This way of labeling the K-map, if you make a habit of it, always label the K-map in this way, you will find all the possible combinations in your K-map. For example, this 0 is A inverse B inverse, this one is A inverse B, this one is A B inverse, and this one is A B. So you can very easily spot your combination in the K-maps if you label it like this. So we are only going to focus on ones. So this one is actually coming from A inverse and B. So I'm going to find out where A inverse and B are intersecting each other, and in that box I'm going to write a 1. This one is actually coming from A, B inverse. So I'm going to find A and B inverse intersection and I'm going to put a 1 there. And this last one is actually coming from A and B. So I'm going to place a 1 in the intersection of A and B. Now, then as you can see, all the ones are grouped together. Now let's see what are the rules of grouping the ones and what are the rules of making the K-map. And then we would go on to do an example. So first is that we are only going to consider cells which have 1 in it. The cells containing 0 are not considered in solving of the K-map. Then all the cells that contains ones, they are identified and they are grouped in the shape of columns or rows or rectangles. The groups are always in even numbers. Means if you are having 3 consecutive ones, you're going to group in the groups of 2 or 4 or 8, not in the odd numbers. You can make the group as large as possible. You can make a group of 4, you can make a group of 6, or you can make you can make a group of 8, you can make a group of 2. In the powers of 2, you can make the groups, and a 1 can be a part of multiple groups. A 1 can belong to more than one groups. And if an individual cell cannot be contained in any group, it is just added at the end of the K-map in the answer. Now let's try to put these rules in motion. Let's see how we actually going to solve these rules. Let's suppose we have this truth table with us. Now in this truth table, we have 8, since there are 3 inputs, we have 8 rows. And in these 8 rows, I'm having first, third, fourth, seventh, and eighth. These 5 are actually ones. So I'm actually concerned with only these. How am I going to plot it? The simple way of doing that is, again, draw a table of 8 cells. As you see that you are having 3 inputs, so you are going to require 8 cells to represent all of their outputs. Again, I'm having A on my y-axis and BC on my x-axis. So A is 0, 1 and BC is 0, 0, 0, 1, 1, 1 and 1, 0. The first one is actually signifying B and the second one is signifying C. So this 0, 0 means B inverse, C inverse. This 0, 1 means B inverse, C. This 1, 1 means BC and this 1, 0 means B, C inverse. If you see this A here, the 0 means A inverse and the 1 means A. So now when I join these columns, I can find all the possible 8 combinations of this truth table. This is actually showing me, this diagonal line on the top left corner is actually showing me that A is actually on the rows and BC are actually on the columns. Apply these rules as they are. You will not face any difficulty in labeling your K-map. Then it's just a process of placing ones in it. This first one belongs to A inverse, B inverse, C. So I have to find A inverse, B inverse, C, which is my first cell on the upper row on the left. So I'm going to place a 1 there. Then I have this one in the third row of truth table, that is A inverse, B, C inverse. So I'm going to find A inverse and then I have to find B, C inverse, which is this last cell of the upper row on the right. Then for this third one, I have to find out, which is actually coming from 0, 1, 1 means A inverse, B, C. So I actually have to find A inverse, which is this upper row, and BC, which is this second last from the right. So A inverse BC 0, 1, 1. The box has been found and we have placed a 1 in it. Then we have this second last one, which is 1, 1, 0, means it's A, B, C inverse. So this is the A row and I have to look for B, C inverse, which is 1, 1, 0. That is going to be this column, this cell on the right in the lower row. And then the last one is actually coming from 1, 1, 1. So I'm having ABC, which is in the second last cell of my K map. So I'm placing a 1 there. So as you can see, we first of all find out all the products and then we wrote them as sum of products. This A inverse B inverse C is this one. This A inverse B C inverse is this one in the third row. This A inverse B C is this one in the fourth row. A B C inverse is this one in the second last row of the truth table. And then you have ABC, which is the last row of the truth table. So these all products are being added together, and this thing is actually called sum of products, or sometimes simply min terms. Now we have actually grouped our K-map as well. As you can see, the first and last columns of K-maps are actually considered joined together. If they have one, so they can be grouped together. So this dotted line is actually showing that this last one is actually grouped with this first one. And these four ones, as we have discussed that we can make the groups in 2, 4, 8. So these four ones are grouped together in a bigger group. Now let's see how we are actually solving this. This is the K-map that we had, and this first group is actually having all the ones that we plotted in the K-map. So A inverse BC is actually, this is the A inverse and this is BC. So it is this one, the second last one. Then A inverse B dot C. So we have A inverse B dot C is this last one on the upper row. Then we have ABC, which is the second last cell. And then we have ABC inverse, which is the last cell of the K-map. Then we have to remember this little Boolean property, which is a part of your first lecture. If you have gone through the properties of Boolean algebra, the theorems, that any variable, if it is added with its own inverse, it actually equals 1. If the value of A is 0, inverse would be 1. So 1 plus 0 is 1. If the value of A was 1, the inverse was 0. So 0 plus 1 was 1. So any variable when added to its own inverse, it results in 1. So after plotting that, we simply try to find out the commons, which is this A inverse B. And when I take the common, it's C plus C inverse, which is left. And from these two, I'm going to take the common of AB, and C plus C inverse will be left inside. And by using this property that A plus A inverse is equal to 1, this C plus C inverse is going to become 1, and I would be left only with the A inverse B plus AB. Then again, from this I can find that B is common. So A inverse plus A will be left inside, and again that is going to become 1, and B dot 1 is simply B. So I'm not going to do that step again and again. And from the first group I have the answer B. From the second group, this is the second group, these two ones with the ones that have dotted lines around them. So I have A inverse, B inverse, C inverse, and I have A inverse, B, C inverse. What I'm going to do is find the common among these, and A inverse and C inverse are common. So we will be left with B inverse plus B inside, which is going to become 1, and A inverse, C inverse, it would be our answer. To write the answer, we are going to simply add the answers of both groups. What we are going to do, we are going to write the answers of both groups, which is B, means the answer of first group, plus A inverse, C inverse, which is the answer of the second group. When you are actually trying to make the 4-input K-map, the only difference that is going to be that you have AB on your y-axis and you have your CD on your x-axis. The rules of labeling them would still remain the same. The same row that you had on top, you're going to have the same thing on the columns as well. 0, 0, 0, 1, 1, 1, 1, 0. First is A, the second is B. On the column side, if you look at CD, that 0, 0, 0, 1 and 1, 1 and 1, 0 are still the same. But here they are actually signifying the first bit is C and the second bit is D. 2 raised to power 4 is 16. So you can see that we have made a K-map of 16 different cells, and now you can easily see which of them are actually grouped together, and you can find out their solution. You don't have to actually solve this one. I have prepared a worksheet for you on which you can practice. Let me just summarize the rules of solving the K-map questions again. Find out how many variables you are having. Take that as the power of 2. That is going to become the number of cells that you are going to have in your K-map. Once you have that, draw a K-map of those many boxes. For example, in this picture, I had 2 raised to power 4, A, B, C, D, 4 inputs. So I actually made a table of 16 cells. 2 raised to power 4 is 16. Then comes the labeling. And when you have to do the labeling, always follow the scheme that I have showed you on the top here. Go with 0, 0, 0, 1, 1, 1, and 1, 0. If you had 3 variables, you only will have A on your left side. On your rows, you only have A. And if you had 4 variables, you will have AB on the lower side and CD on the upper side. Now, this is not hard and fast rule. You can actually change the layout of your K-map. For example, if you choose to put CD on the lower side and AB on the top side, it is not going to affect your answer. It will affect the way your K-map is going to look like. It might actually make the process of simplifying lengthier, but it is not going to affect the answer. You can change the layout of your K-map, but I advise you to go with this because it would, first of all, it is the one which is being followed by our book and our exam questions. And secondly, it actually gives you an optimized look on your K-map, helps you in simplifying your groups easily. So do the worksheet. If you have any question answers, we are moving to the question answer session right now, and you can email the worksheet back to me on the given email address as soon as you are done. Stay safe. Allah Hafiz.